Okay? I want you to see some of the examples. I cleaned up some of them, so hopefully it'll help you a little bit more through today. So what happens here today is we're going to go back into working with f of x and g of x. We're going to be dealing with composites of functions, adding functions together, subtracting functions, multiplying and dividing. But all of our same rules still apply with all of our exponent stuff. But it all stems back to the same basic premise. Remember when we had f of x and g of x before, I'd give you guys something like 2x plus 1, and g of x is x minus 4. We'll say those were our two functions. Before I'd ask you guys what is f of 3. What would you do? Are you doing electrical work?
You would substitute.
It's substituting what?
Substituting again.
And for which what? F or G?
F.
Why is it F?
Because it says F.
Very good. You'd substitute 3 into the x, and you get 2 times 3 plus 1, and you guys remind with 7. Good. What's going to change today is that it's going to look like this. What is f of x plus g of x?
Okay.
All right. What is f of x according to what I gave you?
3.
7.
That would be f of 3. F of x is, and what's g of x?
X minus 4.
What would you do? Combine like terms. You get 3x minus 3. This same exact rule would apply if I said, what is f of x minus g of x? I'd write down the f of x equation, which was 2x plus 1. Careful. Minus x minus 4. So you have to remember to distribute the x value as you do that. That's the only one of the concerns you'll have. And then you, again, combine like terms. We get x plus 5. Okay? What's going to change a little bit today, not only are you going to be using these, in these examples here, we're just plain old boring linear stuff. Today we're going to have the weird exponents. That's all. So you just have to be careful with your exponent rules. You might have fractional exponents where you have to multiply things together, add them together, things like that. But it's the same basic premise. There will be one twist, though, and we'll come back to that here in a little bit.
It involves division. Yes.
Nah, division really isn't all that bad. It's when you have composite functions, when you're substituting f of g of x. That's a little bit of the weird stuff. So here, let's look at one that starts out like this. I have f of x is 2x to the 1/2, and I have g of x is negative 6x to the 1/2. So when I start this, and I want to figure out what f of x is plus g of x, again, all I have to do is just rewrite down what f of x is, what g of x is. So f of x is 2x to the 1/2, and g of x is? Now think about the rules of combining like terms. Do those guys have the exact same variable and exponent?
Yes.
Can I add them together?
Yes.
What's 2 plus negative 6?
Negative 4x.
Good. And your answer is negative 4x to the 1/2. And I'm done. Because I'm a jerk. Why would I want to do that? Nah. Again, same exact idea going the other way. We're doing subtraction. We rewrite out what it is, 2x to the 1/2 minus a negative 6x to the 1/2. What do you get? 8x. You all right? Do you think anything changes when you have to multiply?
Yes.
No, not really.
Not at all.
Do you have to
Nothing.
Not really, but you just have to follow what rules do you think?
multiplication?
Yeah, you got to follow your exponent rules. The same things are all going to work. Nothing's really changing up here. We just got to pay close attention to the rules with the exponents. When you're multiplying things that have the same base, you add their exponents. When you're dividing things that have the same base, you have to play that game of war. Does the number in the numerator win versus the number in the denominator? Remember, whoever wins in the game of war gets the exponents. Exactly. So in this example here, I have f of x is 3x, and g of x is x to the 4th. When I want to multiply those two equations together, I take my f of x is first, so it's 3x times x to the 1/4. Do those guys have the same x or same variables? Yeah. Both an x variable, isn't it? So it's the same base. What are the but they have different exponents, correct?
Yeah.
One of them is a what?
One.
The other one is? What's 1 plus 1/4? 5/4. Thank you. So my final answer is 3x to the 5/4. Remember, there is no such thing as a mixed number, ladies and gentlemen. You left that in middle school.
I don't understand why.
Yeah.
Why?
Yeah.
What happens is the further you go in math, the more that top-heavy fraction becomes easier to work with. In second semester, when we get into trigonometry stuff, and we start talking about the unit circle, you're going to see one of the real reasons why we don't use mixed numbers. It becomes real evident.
But you can still put it in an answer and it would mean the same thing.
I know, but I don't want you guys to use mixed numbers. Yeah, because then you have an exponent of x to the 1 and 1/4. All right. Albeit, you're right, it means the same thing, but I'm trying to get you guys to stop doing that. Same thing with division. Again, when I'm doing my division here, I wind up with 3x divided by x to the 1/4. Who wins in the battle of war? 1 or the 1/4?
1.
Okay. What's 1 minus 1/4? Okay. So your final answer becomes 3x to 3/4. I'm using the same properties that we were talking about yesterday, as well as the same properties we looked at in chapter 6. None of those have changed. You just have a fraction. Okay? So far, so Gouda? It's like nacho Gouda?
That doesn't make sense.
You don't make sense.
Any harder.
And then last, the weirdest of all. What were the two first f of x shows I gave you guys? What was what f of x was?
2x.
The composite of functions is the weirdest of all of this. The composite of functions means that we're going to combine the two functions into one new function. It's going to look like this. What is f of g of x? Remember, anytime you see something that is written in this function notation, whether it's f of 3, you knew to take the 3, you would substitute it in for x and solve. If it said f of car, you'd take the car, you'd substitute it in for x and go. If it said f of sure, blah, 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 blah. You put it and go for there, all right? Same idea here. It's f of g of x. So what is it telling me to substitute in for x? G of x. Which is what?
X minus 4.
Okay.
Let's do this circle thing.
It doesn't always work for me. It's really annoying. So again, that means I'm going to take the g of x equation and I'm going to substitute in for x. I get 2 times x minus 4 plus 1. F of car, 2 times car plus 1. F of potato, 2 times potato, and so on. Just 2x minus 8 plus 1 is 2x minus 7. Okay. If I wanted to do g of f of x, what's the innermost parenthesis working with? All right, so it's working with the f equation, right? The f of x equation. So that means take the f of x equation and put it where? Where? In the g of x, exactly. Now in this one, it's saying take the f equation and substitute in to the g. So you get 2x plus 1 minus 4, otherwise known as, pretty good. Now, the examples here are all linear, pretty simple. You don't have to worry too much about any exponent rules. Well, but if you follow your exponent rules, it's the same generic principle. Take one equation, substitute in the other, and multiply it out. You follow the exact same rules. So we're going to look at 3 different ways of doing this. So, and f of x is 3x to the negative 1. G of x is 2x minus 1. And I want to figure out what f of g of x is. So, what am I substituting in for x for in the first one? Good. Now, you have to be careful here. What is being raised to the negative 1 power? The 3, the x, or 3x? It's just the x value is being raised to the negative 1 here. The reason is because it's after the x. If it was in parentheses, then it would be through all of it. But since it's just at the last term, that's how that works. So you wind up with 3 times the parentheses, 2x minus 1, negative 1 power. So now what's not happy? The 2x minus 1. Where will it be happy? And you're done. Is it okay if I took it out of the parentheses for the denominator now? It's fine because it only had an exponent of 1. If it was squared, I'd have to leave it in the parentheses and leave the square out there. But since it's just an exponent of 1, it's okay. Would it be all right if you left it in there with a 1? And that's that. Same idea, go in the other direction. If I want to know what g of f of x is, now I have to take the f of x equation and substitute into there. Which means in this example, we wind up with 2 times 3x to the negative 1 minus 1. What's not happy? Just the x. Remember, I just talked about that. The only thing that has the variable that's negative is x. So what's 2 times 3? 6. So it becomes 6 over x minus 1. The only thing that wasn't happy was the x. That was the only part that wasn't happy. When you are throwing in the grouping symbols here, it's 2 times 3 times x to the negative 1. Yeah?
Why isn't the 1 on top of the 6?
Because it's not being multiplied by the x. The only thing that's being multiplied by the x value, with x to the negative 1, excuse me, it was the 2 times 3. The minus 1 is just tacked on later. It would have looked different. Okay? It would have had parentheses around all of it.
Oh, I get it now.
Have you written any of it down?
Yes, I have.
Very good. What do you do with the last one then, do you think? You use it, yeah, you put it in for itself. You're substituting it for yourself. That works, but that's all that is. So our f of x equation was, let me write this in. I showed it this way last hour. I showed it this way last hour by saying that since you're substituting it in for itself, sometimes it's easier for people to see if I write out the f of x equation twice and then just kind of draw it out that I'm going to take this and substitute into that value of x. So you wind up with 3 times the quantity, because the x value is being raised to the negative power of 3x to the negative 1. Yeah.
So because the one is on the outside, the outside as well as the inside.
Yes. Well, no. The reason why this one is on the inside here is because it's part of the f of x. The reason that this one is on the outside is because it's going to the value of x. Since I'm substituting in for the x, no matter what goes in here, it still has to be raised to the negative 1 power. All right.
So it would like say it was like x cubed or something, and then it would like
Yeah.
outside of the two.
Yeah. Exactly. So now you have to use your exponent rules when you are raised up with power to power. Things like this. So you're basically going to distribute that negative 1 power to all the terms within the parentheses. So you wind up with 3 times 3 to the negative 1. And then what's power to power here? What's negative 1 times negative 1? 1. What is 3 to the negative 1? 1/3. What's 3 times 1/3? 1. So your answer is? No. X doesn't equal x here. F of x equals x.
Does that work for which makes no sense?
Right.
X equals
So
X.
basically it's saying one equals
Not necessarily.
one.
I get your eyes checked.
Ask him, this is so good.
What's up?
She did right. She said she was right.
I'm always right.
She's saying that.
You're on his right. I'll give you that.
Yeah, one over X.
Everyone's laughing. If you're looking at me, I'm laughing.
Let's see.
You're up, my
Take a second and do the 2 composites with those 2 equations, with those 2 functions, or with those 2 functions here. What I try to do here is just same basic principle, and try to see if you can figure this out. Is x minus 1, yeah. 4x squared for f of x, and x minus 1 for g of x.
No, you just took them off my
You're a jerk.
What? Thanks, then.
Again, as you get into this, f of g of x, you're taking the 4, you're substituting x minus 1 quantity squared. That means it's 4 times x squared minus 2x plus 1, which is 4x squared minus 8x plus 4. Remember, junk squared is junk times junk, ladies and
I
gentlemen.
have just killed a dog.
You have just killed the puppy.
Square box.
Is that plus 4?
Oh.
That is a plus.
Mr. Murphy's going.
That's a minus 4.
Mr. Silver's
That is a plus. Okay. Sorry, I'm partially blind all the way.
And then again, when you go the other direction, you get 4x squared minus 1.
I am in so much.
Could you factor that?
You really wanted to.
If you really wanted to, you could. It's a difference of squares. You don't have to worry about it, but I'm just saying. That's the basic principles you got to watch out for, guys. When you have junk squared, remember that's junk times, but this, again, this means x minus 1 times x minus 1.
Oil or fat or
You did it too.
Mr. Murphy?
You have killed the puppy.
Mr. Murphy, can you FOIL the 4x squared minus 8x by splitting the.
Yeah, you're gonna get. Because that's what I started with. You will be pleasantly surprised. You should be pleasantly surprised that these aren't as awful as what you're probably expecting. You're still using the same properties and stuff like that. Again, ladies and gentlemen, guys, I let you guys hold on to that stuff from yesterday, so that way if you do have extra questions and all that, you can ask some more of it tomorrow. Make sure you go through it. Try a couple more of those odd problems, because you will see that stuff on that quiz on Friday. Because we will be going over we'll go over this stuff tomorrow and talk about writing inverse equations. Inverse equations really are not all that difficult as well, but what I'll come back to get you guys will be probably that section 7.2. So make sure you spend some time rechecking over 7.2. I know there's no flex today, but you still got tomorrow. All right? I'll be here in the morning about 7:15, I'm guessing. I got to take the boys into the center tomorrow, so I'll be here a little bit later. All right?
Do they not go to school? Sure I do.
Sure.
Oh, wait.
So